You ever stop to think about the ground beneath your feet as, like, a giant history book? Seriously. Every mountain, every river, every single rock tells this incredible story of immense power and, well, unbelievable patience. So today, we're going to learn how to read it, how to decipher the autobiography our planet has been writing for billions of years. I mean, just look at this. This is the Taroko Gorge in Taiwan. It's an absolute masterpiece of natural sculpture. You're looking at a river, the Liwu River, that has literally sliced right through a mountain of solid marble. So how? How does that even happen? How can flowing water, something you can scoop up in your hands, take on solid rock on this kind of epic scale? That's the mystery we're going to unravel. Okay, so to figure out how a canyon is even born, we first need to meet the artists. These are the powerful forces, some of them incredibly slow, others terrifyingly fast, that are constantly sculpting and resculpting the face of our world. So who are these sculptors exactly? Well, you've got the explosive power of volcanoes and the ground-shaking force of earthquakes. Then there's the patient, grinding power of wind and ice. And yeah, increasingly, there's us, human activity. But the one that's the most persistent, the most powerful, and the most widespread sculptor of them all, yep, it's water. And that brings us right back to our river. Rivers are really the main characters in this story, the primary authors of the landscape. See, they do their work using three key moves, and this is happening all the time, all day, every day, all over the world. First up, you have erosion. This is basically the carving and cutting part of the job. The river, armed with all the sand and gravel it's carrying, acts like liquid sandpaper. It just relentlessly grinds away at the rock, bit by tiny bit, over thousands and thousands of years. Now, once a piece of rock gets broken off, it's not just going to sit there. The river acts like this giant conveyor belt in a process we call transportation. It scoops up all that eroded material, everything from huge boulders to tiny little grains of sand, and just carries it downstream. But eventually, that river is going to get tired. It starts to lose energy. As it slows down and widens out, it just can't carry that heavy load anymore. So what does it do? It just drops it. This is called deposition. And it's not an ending, it's actually a new beginning. This is how new land gets built, creating everything from sandy beaches to those huge, fertile river deltas. This whole process creates a river's life story, and you can almost think of it as having a personality that changes along the way. So way upstream in the mountains, the river's like a wild teenager. It's fast, it's energetic, and it's powerful, carving out these deep V-shaped valleys. Then in the midstream, it starts to mature a bit. It slows down, it widens, and it tumbles all those sharp rocks until they become smooth, rounded pebbles. And finally, when it gets down near the sea, it's like it's old and slow, gently dropping off fine sand to build up vast, flat plains. So, we've been talking a lot about rocks getting broken down and carted all over the place. But what are these rocks, really? What are the fundamental ingredients the Earth is using to build everything we see? Well, the answer is actually pretty simple. All rocks are made of minerals. A really good way to think about it is this. Minerals are your ingredients. You know, flour, sugar, eggs. And the rock is the cake you bake at the end. Some cakes, like limestone, have just one mineral ingredient, but others, like granite, are a mix of a whole bunch of them. And you can combine these mineral ingredients in three basic ways, which gives us our three main types of rock. First up, you've got igneous rocks, which are literally born from fire. They form when molten lava cools down and gets solid. Next, there are sedimentary rocks. These are built from pieces of the past, like layers of sand and debris getting squeezed together over millions of years. This is where we find fossils, by the way. And finally, you have metamorphic rocks. These guys are transformed by insane heat and pressure deep underground, changing one kind of rock into a totally new one, like limestone turning into marble. It's nature's ultimate recycling program. Okay, now this is where the story gets really, really cool. Because sometimes when those sedimentary rocks are forming, they trap these incredible little clues about what life was like millions and millions of years ago. We call these clues fossils. And we are not just talking about giant dinosaur bones, okay? A fossil can be the delicate imprint of a leaf, the shell of an ancient sea creature, or even fossilized footprints left behind when an animal walked across some mud. Every single one is like a perfect snapshot from a world that's long gone. What's amazing is that these rock layers basically form a timeline, letting us read Earth's history in order.
By seeing which fossils show up in which layers, we can piece together the whole story of life. So if you find a trilobite, boom, you know you're looking at the ancient Paleozoic era. A T-Rex bone, you're in the Mesozoic. And if you find a mammoth tusk, that tells you you've reached our most recent era, the Cenozoic.
Okay, so up to now, we've been all about the slow and steady, the patient forces that take millions of years to do their work. But Earth's autobiography also has these really violent, sudden chapters. Let's turn to one of the most powerful of these forces, earthquakes.
7.2. That's not just a number. That was the magnitude of the earthquake that struck Hualien, Taiwan on April 3rd, 2024. It's a single number that represents this incredible release of energy from deep inside the Earth's crust, powerful enough to change the landscape in just a few seconds.
And that brings up something really crucial that a lot of people get confused about, the difference between magnitude and intensity. Okay, so an earthquake has only one magnitude. That's 7.2 number. That measures the total energy it unleashes at the source, but it can have many different intensity values. Intensity is all about how strongly the ground actually shook in a specific spot. That's why someone standing right near the epicenter feels it violently, but someone miles and miles away might only feel a little tremor. So, what does all this tell us? It tells us we live on this absolutely beautiful planet, but it's also a restless one, and sometimes a pretty dangerous one. So, what's the big takeaway here? How do we appreciate this incredible story and also keep ourselves safe? First things first, and this is super important, you have to know what to do when the shaking starts. It's just 3 simple words, but they could save your life. Drop, cover, and hold on. Drop to the ground. Get under something sturdy like a table to cover yourself and hold on tight until it's all over. This simple action is your absolute best defense against falling objects, which is a major cause of injuries during a quake. And you know, looking beyond our own safety, we've got a shared responsibility here. All these incredible landscapes we've been talking about, they're literally the pages of Earth's history book, and it's on us to be its librarians. By supporting things like geoparks and nature reserves, and just by trying to tread a little more lightly on the land, we can make sure these stone pages don't get ripped out, so the story can be read for generations to come. I mean, think about it. The Earth has been writing its own story for more than 4.5 billion years. A story of fire and ice, incredible pressure, and just immense patience. We are living in the latest chapter. We are actively writing it right now. So the real question we're left with is, what will our contribution to the story be?